Greenland is melting 3 times faster than scientists predicted just 15 years ago, and the reason why might terrify you more than rising sea levels ever could. Everyone talks about climate change like it's some distant abstract threat. But what's happening to this massive ice sheet right now is rewriting everything we thought we knew about how quickly our planet can transform. You probably think you understand why polar ice melts. You don't. Not really. Because the real story involves hidden mechanisms beneath 2 miles of frozen water that scientists only discovered by accident. And in a moment, you'll see why this changes everything. Picture this. The entire Greenland ice sheet holds enough frozen water to raise global sea levels by over 23 feet. That's not a typo. 23 feet. Every coastal city on Earth, gone. Miami, Bangkok, Amsterdam, Shanghai, completely underwater. But here's what nobody tells you about Greenland's ice melt, the part that keeps glaciologists awake at night. It's not melting from the top down like you'd expect. It's melting from the bottom up. And the mechanism driving this is so wild that when researchers first proposed it, their colleagues thought they were losing their minds. Let's rewind to 2008. A team of scientists drilling into the Greenland ice sheet expected to find solid ice all the way down to bedrock. Standard stuff. Instead, their drill hit something they didn't anticipate at 700 meters deep. Liquid water. Massive rivers of meltwater flowing underneath billions of tons of ice, lubricating the entire sheet, like oil on a highway. This discovery flipped polar science upside down because it meant the ice wasn't just melting, it was sliding. The question everyone asked was simple, but horrifying. How fast could it move? And in a moment, you'll discover what happened when they calculated the answer. Now, here's where the map perspective becomes critical. When you look at Greenland on a standard map projection, it appears roughly the size of Africa. That's the Mercator distortion lying to you. In reality, Greenland is about 2 million square kilometers, roughly the size of Mexico and Alaska combined. But that massive landmass sits almost entirely above the Arctic Circle, meaning it receives less direct sunlight than anywhere else on the planet, except Antarctica. For millennia, this geographical position kept Greenland locked in a stable deep freeze. The ice accumulated year after year, building that colossal sheet to an average thickness of over 1.5 miles. When ancient Norse settlers arrived around 985, they found fjords and coastal valleys, but the interior was an impenetrable fortress of ice. Eric the Red famously called it Greenland as marketing propaganda to attract settlers, even though the vast majority was white. That ironic name stuck for over 1,000 years. But the irony is about to get much darker. Fast forward to the 21st century. Satellite data reveals something shocking. The ice isn't just melting during summer anymore. It's melting in winter, too. In January 2012, researchers detected surface melt in the middle of the polar night, when Greenland receives almost zero sunlight. How is that even possible? The answer involves a feedback loop so vicious, it makes normal climate change look gentle by comparison. And this is the part most documentaries skip because it's complicated. But stick with me, because understanding this mechanism is the key to everything. The Greenland ice sheet is bright white, which means it reflects most incoming solar radiation back into space. Scientists call this albedo effect. High albedo equals cool surface. But when ice starts melting, even slightly, it creates something called melt ponds. These are pools of liquid water sitting on top of the ice sheet. Water is much darker than ice, so instead of reflecting sunlight, it absorbs it. That absorption creates more melting, which creates bigger ponds, which absorb even more heat. It's a runaway process. Once it starts, it accelerates exponentially. By 2012, Greenland experienced its most extensive melt event in recorded history. 97% of the surface showed signs of melting. 97%, including areas that hadn't melted in centuries. But surface melting is only half the nightmare. Remember those subglacial rivers scientists discovered? They're not just sitting there, they're carving channels through the bedrock, creating highways for meltwater to reach the ocean. When water flows beneath the ice sheet, it doesn't just lubricate the base, it also transfers heat from the relatively warmer ocean up into the ice from below. The Greenland ice sheet is essentially being attacked from both sides simultaneously. Solar radiation from above, ocean heat from below. It's getting cooked in a planetary oven, and the temperature keeps rising. Now, let's talk about what this means for the rest of the world. And trust me, it gets worse. Greenland's ice melt doesn't just raise sea levels. It disrupts the Atlantic meridional overturning circulation, a critical ocean current system that regulates climate across Europe, North America, and beyond. Cold fresh water pouring off Greenland into the North Atlantic changes the ocean's salinity and density, which can slow or even shut down these currents. Some models suggest we're already seeing this slowdown. If the Amo Sea collapses completely, Europe could experience winters colder than they've seen in centuries, even as the planet overall continues warming. Imagine London getting Siberian winters while Miami drowns. That's the paradox we're heading toward, and Greenland's accelerating melt is pushing us closer to that tipping point every single day. Let me hit you with the numbers that really matter. Between 2000 and 2019, Greenland lost approximately 3.8 trillion tons of ice. 3.8 trillion. To put that in perspective, if you took all that ice and melted it into drinking water, you could give every person on Earth over 500 liters per day for an entire decade. But instead of drinking water, it became sea level rise. About 10 millimeters of global sea level increase came from Greenland alone during those 19 years. That might not sound like much, but coastal engineers will tell you that every millimeter matters when you're trying to protect infrastructure worth trillions of dollars. And here's the truly wild part. The rate of loss is accelerating. What took a decade in the early 2000s now happens in about 5 years. What took 5 years now happens in 2. If this trend continues, and every indication suggests it will, Greenland could contribute over 30 centimeters to sea level rise by 2100. That's conservative. Some projections go much higher. Now you might be thinking, okay, this is bad, but surely someone has a plan to slow this down or reverse it, right? Well, here's the uncomfortable truth that nobody in power wants to say out loud. We don't. There is no plan. Greenland's ice sheet has approximately 3 times the thermal inertia of the entire atmosphere. That means even if we stopped all carbon emissions tomorrow, completely halted every coal plant, every car, every emission source on Earth, the ice would continue melting for decades, purely from the heat already trapped in the system. We've already baked in centuries of melting. The question isn't whether Greenland will lose massive amounts of ice. It's how fast and how much. Let me take you to Ilulissat, Greenland's third largest town, with a population of around 4,600 people. It sits right next to the Ilulissat Ice Fjord, a UNESCO World Heritage Site and one of the most productive glaciers in the Northern Hemisphere. The Cermek-Kujalek Glacier that feeds this fjord produces over 46 cubic kilometers of icebergs annually. That's roughly 10% of all icebergs calving off Greenland. Locals have watched this glacier their entire lives. In the past 20 years, they've seen it retreat over 15 kilometers inland. Massive chunks of ice the size of Manhattan break off and float out to sea with increasing frequency. Fishermen report navigating through iceberg fields that didn't exist when their fathers fished these same waters. The traditional hunting grounds are changing. Species are migrating. The entire ecosystem is transforming in real time. And these people, who have lived in harmony with this ice for generations, are witnessing the collapse of their world with their own eyes. But here's something almost nobody talks about, and this might be the wildest part of the entire situation. Greenland's ice melt is exposing land that hasn't seen sunlight in over 100,000 years. As glaciers retreat, they reveal ancient tundra, valleys, and riverbeds frozen in time. In some areas, prospectors have discovered massive deposits of rare earth minerals, the kind critical for manufacturing smartphones, electric vehicles, and renewable energy technology. There's uranium, zinc, lead, and potentially vast reserves of oil beneath the ice. Greenland, a territory of Denmark with a population of just 56,000 people, is sitting on estimated natural resource wealth valued in the trillions. Multiple countries, including China and the United States, have expressed strategic interest in Greenland's resources. In 2019, President Trump reportedly inquired about purchasing Greenland outright, an offer Denmark called absurd. But the geopolitical implications are deadly serious. As the Arctic becomes more accessible due to melting ice, it becomes a new frontier for resource extraction, military positioning, and territorial disputes. Climate catastrophe is creating a resource bonanza, and the world's superpowers are already positioning themselves to exploit it. Let's discuss the military angle for a moment, because this adds another layer of complexity most people never consider. The United States maintains Thule Air Base, also known as Pituffik Space Base, in northwestern Greenland. It's one of the most strategically important military installations on the planet, hosting early warning radar systems that monitor missile launches and space activity over the Arctic. As sea ice melts and new shipping routes open through the Arctic Ocean, Greenland's geographic position becomes even more valuable. The Northwest Passage, a sea route through the Arctic Ocean connecting the Atlantic and Pacific, could become navigable year-round within decades. This would revolutionize global shipping, cutting transit times between Europe and Asia by thousands of kilometers compared to routes through the Suez or Panama canals. But it would also create new security concerns. Who controls Arctic waters? Who regulates traffic? Who responds to emergencies? Greenland sits right in the middle of these emerging strategic pathways, and its ice melt is literally reshaping the geopolitical map. Now, let me explain the feedback mechanism that makes Greenland's situation uniquely terrifying compared to other ice sheets. Antarctica, massive as it is, sits on a continental landmass surrounded by ocean. Most of its ice sheet rests above sea level on solid ground. Greenland is different. Large portions of the Greenland ice sheet sit in basins where the bedrock surface lies below sea level. This creates a vulnerability called marine ice sheet instability. When the ice front retreats into deeper water, more of the glacier's base becomes exposed to relatively warm ocean water. This accelerates melting from below, causing further retreat, which exposes even more ice to warm water, triggering faster melting in a vicious cycle that can become irreversible. Scientists call this a positive feedback loop, though there's nothing positive about it. Several of Greenland's major glaciers are experiencing this exact process right now. Jakobshavn Glacier, Helheim Glacier, and Kangerlussuaq Glacier have all shown dramatic acceleration and thinning in recent years. Once marine ice sheet instability takes hold, stopping it becomes exponentially harder, perhaps impossible with current technology. The human element here deserves attention too. Greenland's indigenous Inuit population has inhabited this land for over 4,000 years, developing deep knowledge of ice conditions, weather patterns, and wildlife behavior. Their traditional lifestyle depends on stable ice for hunting seals, whales, and polar bears. As ice conditions become unpredictable, centuries-old hunting routes become dangerous or impassable. Sea ice that once formed reliably every winter now appears late or not at all in some areas. Elders speak of changes happening within a single generation that they never imagined possible. Younger Greenlanders face an impossible choice: preserve traditional ways of life that are becoming increasingly difficult, or adapt to a modernizing economy increasingly influenced by outside interests, chasing resources, and strategic position. It's cultural erosion driven by environmental collapse, and it's happening right now to a people who contributed virtually nothing to the climate crisis, but are bearing its consequences in the most immediate, visceral ways. Let's address the elephant in the room. You've probably heard people say, we can't really know what will happen because climate science is uncertain or models are unreliable. Here's what that argument misses. The uncertainty in climate science isn't about whether Greenland is melting or whether that causes sea level rise. Those facts are as established as gravity. The uncertainty is about exactly how fast and how much. Will Greenland contribute 10 centimeters to sea level rise by 2100 or 50 centimeters? That's the uncertainty. And here's the kicker. Recent observations consistently show that ice loss is occurring faster than models predicted. The uncertainty has been biased toward underestimating the problem, not overestimating it. Every time scientists revise their projections, the news gets worse, not better. The conservative estimates keep getting overtaken by reality, which means if you're planning coastal infrastructure, betting on the low end of projections is a fantastic way to ensure catastrophic failure. The economic implications spiral outward in ways most people don't immediately grasp. Coastal cities contain the majority of global economic productivity. New York, London, Tokyo, Hong Kong, Singapore, Mumbai. These metropolitan centers represent trillions in real estate, infrastructure, and economic output. Even modest sea level rise requires massive investments in flood defenses, drainage systems, and adaptation measures. The Netherlands has been managing this for centuries with dikes and pumps, but they're a relatively small, wealthy nation with strong institutions. What happens when Jakarta, a megacity of over 10 million people built on swampy ground that's already sinking, faces an additional half-meter of sea level rise? What happens when storm surges powered by warmer oceans push that elevated sea level even higher during hurricanes? We're talking about potential mass displacement of hundreds of millions of people over the coming century, driven significantly by ice melt from Greenland and Antarctica. The refugee crises of the past decade will look tiny by comparison. Here's something that might surprise you. Some of the most detailed research on Greenland's ice dynamics comes from an unexpected source: the petroleum industry. Oil companies spent decades developing sophisticated technology to map subsurface geology for resource extraction. That same technology, ground-penetrating radar, seismic surveys, and computer modeling, proved invaluable for studying ice sheets. Ironically, the industry that contributed massively to the climate crisis also helped us understand the full extent of the damage. Today, many climate scientists use tools and techniques originally developed to find fossil fuels, to instead track the ice those fuels are melting. It's a strange twist of technological history, and it highlights how interconnected these systems really are. Let me bring this back to something concrete you can visualize. Imagine standing at the edge of the Greenland ice sheet. You're looking at a vertical wall of ice rising hundreds of feet above the ocean, stretching away in both directions as far as you can see. Now imagine watching that wall calve. A section the size of a skyscraper breaks off with a crack like thunder, crashing into the water and sending waves surging outward. The sound echoes across the fjord for minutes afterward. This isn't a rare event anymore. It happens constantly, day after day, year after year. Researchers monitoring glaciers with time-lapse cameras capture these calvings repeatedly. Each collapse represents ice that accumulated over centuries, maybe millennia, being returned to liquid water in seconds. It's geological time compressed into real time, and it's one of the most visceral demonstrations of how rapidly our planet is changing. Now, here's the final twist that brings everything together. The melting of Greenland isn't just a consequence of climate change, it's also an amplifier of climate change. Those trillions of tons of ice reflect solar energy back into space. When they melt into dark ocean water, that surface absorbs heat instead of reflecting it, warming the ocean further, which melts more ice, which creates more dark water surface, in yet another feedback loop. Every degree of warming makes the next degree easier to reach. We're not climbing a steady slope towards some distant climate future. We're on an accelerating treadmill that gets faster the longer we stay on it. And Greenland, this massive frozen island that's been stable for tens of thousands of years, is revealing just how fast that treadmill can spin once the brakes come off. So by the end of this video, I hope you understand that Greenland's ice melt isn't just about polar bears or distant islands. It's about the stability of the systems that make modern civilization possible. It's about coastlines, weather patterns, ocean currents, geopolitics, resources, indigenous cultures, and the future habitability of the planet. The real reason Greenland is melting faster than expected isn't just rising temperatures. It's a complex web of feedback mechanisms, geological vulnerabilities, and physical processes that scientists are still working to fully understand. And every year, the situation becomes more urgent, the numbers more alarming, the consequences more irreversible. If you made it this far, you're clearly someone who cares about understanding these complex global issues. Consider subscribing for more deep dives into the hidden mechanisms shaping our world. Hit the like button if this changed how you think about Greenland or climate science. And here's a question for the comments. Knowing what you know now about the speed and scale of Greenland's ice melt, do you think current global efforts to address climate change are remotely adequate? Or are we sleepwalking toward a crisis we're completely unprepared for? I'm genuinely curious what you think. Drop your answer below, and don't forget to check the description for links to the scientific papers and monitoring systems tracking all of this in real time. The data is public, the science is clear, and the clock is ticking. See you in the next one.